And a complex fraction is a fraction where the numerator and or the denominator are also fractions. So a fraction where the numerator and or the denominator is a fraction. So, for example, you could have 1 over x plus 1 all divided by 1 plus 3 over x minus 2. This is an example of a complex fraction where the numerator is a fraction and the denominator is also a fraction. I could also have something like this. A to the power of negative 2 plus b to the power of negative 1 all over 1 over a. Well, the numerator is actually a fraction because if you think about your properties of exponents, this is really 1 over a squared plus 1 over b all over 1 over a. So the numerator and the denominator are both fractions. So these are examples of complex fractions. So what we're going to be doing today is simplifying our complex fractions. So this is basically the rules you're going to follow. First, you're going to work with the numerator, and you're going to simplify it. And then you're going to work with the denominator, and you're going to simplify it. And then you're going to combine those two together, factor and cancel like factors, and multiply across. So let's give an example here. So 3/4 minus 1/8 divided by 2 plus 1 over 12. So I'm going to start working with the numerator. And so I've got 3 over 4 minus 1 over 8. Well, you guys all know you need a common denominator here, so I'm going to multiply by 2. So that gives me 6 over 8 minus 1 over 8, which is 5 over 8. And I'm going to do the denominator here. So I have 2 plus 1 over 12. Well, 2 is the same thing as 2 over 1. I'm going to multiply by 12. That's my clever form of 1. 12 over 12 is really just 1. So when I multiply by 12 over 12, I'm not changing the expression. I'm not changing what it is. I'm just changing what it looks like. So this becomes 24 over 12 plus 1 over 12, which is 25 over 12. Now I'm going to take my two answers, 5 over 8 and 25 over 12, and I'm dividing them because this is my numerator and the other is my denominator. Actually, I'm going to do some different colors. Okay, there's my numerator, there's my denominator. So that's that part, and the top is my yellow part here. So I'm going to divide them. So I have 5 over 8 divided by 25 over 12. So what we've done is we've finished step 1. We combined fractions in numerator and fractions in the denominator. So I'm going to rewrite them as a horizontal division problem. So this is really just 5/8 divided by 25 over 12. Check. So when you divide, you're really multiplying by the reciprocal. So this is 5 over 8 times 12 over 25. And I'm going to multiply across. So we multiplied by the reciprocal. This is really multiply by reciprocal. And I'm going to simplify here. So I know that 5 and 25 can simplify, so that becomes a 1 and that becomes a 5. I know 12 and 8 simplify, so that becomes a 2 and that becomes a 3. So I end up with 3 over 10, multiplying straight across. And so that's that. So this is my final answer. Okay. So let's look at some more examples here. need some extra space. Alright, so first I'm going to start with my numerator. 2 minus 1/2. So I know this is really 2 over 1. So I have to multiply by 2, multiply by 2. So that gives me 4 over 2 minus 1 over 2, which is 3 over 2. So there's the answer for my numerator. That's that. Okay, now the denominator. Do a different color. So I have 1 minus 1/4. This is really 1 over 1, so times 4 times 4. I get 4 over 4 minus 1 over 4, which is 3 over 4. And so that corresponds to my denominator. So now I'm going to rewrite this as 3/2 divided by 3/4, which is really 3/2 divided by 3/4, just written differently. And I'm going to multiply by the reciprocal. So this is 3/2 times 4/3. Well, the 3's cancel. 4 divided by 2 is just 2. So my final answer is just 2. Another example here. And keep in mind, you don't have to do every single example with me. If you understand, you can go ahead and try the homework. But I'll keep working out some problems here. So, properties of exponents. R to the negative third is really 1 over r cubed, plus s to the negative third is really 1 over s cubed, all divided by 1 over r plus 1 over s. So I'm making my negative exponents positive. So here we have a complex fraction. So first I'm going to work out my numerator. I know that I have 1 over r cubed plus 1 over s cubed. I'm going to have to multiply this side by r cubed, and this by s cubed and s cubed. So I end up with s cubed over r cubed s cubed plus r cubed over r cubed s cubed. And this gives me s cubed plus r cubed all over r cubed s cubed. Okay, lots of cubes going on. The denominator, this becomes, this is 1 over r plus 1 over s. So I multiply by r and r, so I get my common denominator, s and s. So I have s over rs plus r over rs. So that ends up being s plus r over rs. And so here's my numerator, and here's my denominator. So I'm going to rewrite this as s cubed plus r cubed over r cubed s cubed, all divided by s plus r over rs. Now that's the same thing as s cubed plus r cubed divided by r cubed s cubed divided by s plus r over rs. Now I'm going to multiply by the reciprocal. So this becomes s cubed plus r cubed divided by r cubed s cubed times rs over s plus r. Now I already see that this rs and this r cubed s cubed is going to simplify, but I also know that this is a sum of cubes. So remembering your sum of cubes formula, this is simply s plus r times s squared minus sr plus r squared. Remember, same sign, opposite sign, always positive. So this factors to be that. Divided by r cubed s cubed times rs over s plus r. Now we get to do the fun part, the canceling. So s plus r and s plus r cancels. The r over r cubed, that's going to become an r squared. And the s over s cubed, that's going to become an s squared. So my final answer is s squared minus sr plus r squared all over r squared s squared. And make sure you're not canceling across addition, right? This plus sign and this minus sign here, make it so you can't cancel the r squareds and the s squareds. And that's your final answer. Okay, next problem was up here. And I'm going to go like this. And put this guy down here. Okay. So I've got 1 minus a. So the numerator doesn't have a fraction in it. I'm just going to leave it. I'm going to look at the denominator. Actually, let's rewrite this first as with positive exponents. So this is the same thing as 1 minus a over 1 over a minus 1. So now I'm going to look at the denominator here. This is 1 over a minus 1 over 1 times a times a. So that gives me 1 over a minus a over a. I have my common denominator, so I have 1 minus a over a. So my numerator stays the same. There's no fraction there. My denominator is here. So I'm going to rewrite this. This is 1 minus a, all divided by 1 minus a over a equals. Now I'm going to kind of skip that rewrite as a division part. I think we have got it down. So this is 1 minus a times the reciprocal. So a over 1 minus a. 1 minus a cancels, and I just get a for my answer. All right, number 5. So let's work with the numerator first. So I'm going to have 1 plus 3 over x plus 2 over x squared. I need a common denominator, so I have to multiply this by x squared, this by x squared, this by x, and this by x. My last term I don't have to do anything to. So I end up with x squared plus 3x plus 2 all over x squared. There's my numerator. My denominator, so I have 1 plus 2 over x. So I got to multiply by x, multiply by x. I get x plus 2 all over x. So there's my numerator, is this guy, and here's my denominator here. So I'm going to rewrite the problem as x squared plus 3x plus 2 divided by x squared, all divided by x plus 2 over x. So now I'm going to multiply by the reciprocal. So that's x squared plus 3x plus 2 divided by x squared times x over x plus 2. Now I'm going to factor and see if there's anything that I can cancel. So I know that the numerator here, it factors to be x plus 2 times x plus 1 all over x squared times x over x plus 2. X plus 2's cancel. This x cancels with this, and this becomes just x in the denominator. So my final answer is x plus 1 divided by x. And make sure you're not canceling these x's here because of this plus sign in the middle. You can't do that. No canceling across addition. All right, next problem. I'm going to get this squished a little bit. So, number 6. The numerator here. Got 1 over x squared minus 1 over y squared. So I know I have to multiply the right by x squared, and the left by y squared and y squared. That gives me y squared minus x squared all over x squared y squared. It's my common denominator. Now down here, in the denominator, I have x over y plus y over x plus 2. So I know my least common multiple is going to be xy. So I need to multiply this by xy and xy. This is missing a y in the denominator, and this is missing an x in the denominator. So this ends up being x squared plus y squared plus 2xy. And this is over xy over xy over xy. So I have my common denominator, That gives me x squared plus y squared plus 2xy all over xy. Now, you'll notice that this is one of those problems where you can rewrite it and use your t-chart to help you factor. It's a trinomial, and if I write it in descending order of exponents for the x and ascending order for exponents for the y, it looks like this. So I know that my leading coefficient's a 1. I also have a 1 here. So I'm going to do my t-chart. 1 times 1 is 1. And I want factors of 1 that add to be 2, my middle coefficient. Well, that's 1 and 1. So now I'm going to rewrite my middle term. So x squared plus 1xy plus 1xy. Notice that I included both the x and the y in the middle term. Plus y squared. Now I'm going to group, factor my GCF so I can factor an x. I'm left with x plus y. From here I can factor a y, and I'm left with x plus y. So my two factors are x plus y times x plus y. X plus y times x plus y all over xy. Alright, getting kind of carried away here. So our numerator. This is my numerator. And way down here, this is my denominator. So I need to rewrite them. Y squared minus x squared divided by x squared, y squared, all divided by my denominator, which is this blue part here. X plus y times x plus y, all divided by xy. Now I'm going to flip the denominator, multiply by the reciprocal, so I get y squared minus x squared over x squared y squared times xy over x plus y times x plus y. Now this part on the top is a difference of squares, so that's y minus x times y plus x times xy all over x squared, y squared, x plus y, x plus y. So these are going to cancel. I also know that this is going to become x and this is going to go away. So x squared and x, this becomes just x in the denominator. And y squared, this becomes just y in the denominator. So my final answer ends up being y minus x divided by xy times x plus y. Kind of a long problem, but there you go. There's your answer. Okay, cool, fun. Last but not least, we have k plus 1 over k minus 2 in the numerator. Minus 2. So I know that here I need to multiply by k minus 2 and k minus 2. That's my clever form of 1. So that equals k squared minus 2k. I'm going to distribute this k inside all over k minus 2 plus 1 over k minus 2. So that gives me k squared minus 2k plus 1 all over k minus 2. There's my numerator. Denominator, here we come. So k squared over k minus 2 plus 1. So I know I need to multiply by k minus 2 here. And so that gives me k squared plus k minus 2 all over k minus 2. So here's my numerator. And here's my denominator. Oops. And here's my denominator. So I'm going to rewrite my problem as k squared minus 2k plus 1 over k minus 2, all divided by k squared plus k minus 2 over k minus 2. So this becomes multiplied by the reciprocal, k squared minus 2k plus 1 over k minus 2 times, flipping the denominator to multiply by the reciprocal, k minus 2 over k squared plus k minus 2. So let's do some factoring here. Let's see if we can cancel something. So the numerator on the left side factors to be k minus 1 times k minus 1 over k minus 2. Numerator here stays k minus 2. And this becomes k plus 2 times k minus 1. Now the fun part. Bam, 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 gone. And we're left with k minus 1 in the numerator and k plus 2 in the denominator. There you go. So, things to remember. Sum and difference of cubes formulas, difference of squares formulas. Don't forget to distribute a negative inside, and go do your homework.